In this video, we'll carry on looking at integration and in particular, looking at how we might work or how we might calculate an area under the curve, and that's using this definite integration. Okay, and in engineering, this is going to have a couple of uses. So just a little reminder, our steps for integration that we saw previously for integrating a polynomial, like powers of x, would be to increase the power by 1, divide by the new power, and we also talked about adding that constant of integration, that plus c. It's just a number that we don't know at the end. Okay, well, let's go back and I'll just sort of mention, so let's say we had a curve here where the curve y is some function of x, which means it depends on x in some way. Okay, what if I wanted to work out the area under the curve? So I wanted to work out the area under the curve. Now, if I want an area, I need to have a shape, don't I? A defined shape. So this shape sort of seems to start on the y-axis. It must end somewhere. So let's make an ending line over here. Let's say this is when x is equal to 1. So we've got x equals 0 on the y-axis, x equals 1 over here, and we've got our curve and the x-axis. So this area, we can use integration to find out. So we could integrate the equation of the curve with respect to x, and where the sort of leftmost side of the shape has an x value of 0, so this is what we call the lower limit. So that's going to go at the bottom of that integral sign. The upper limit in this case is 1, so I'm going to put that up here. So you can see the notation looks slightly different. We have these limits. We've got this upper limit, which is like the right hand side of the shape, the lower limit, which is like the left-hand side of the shape, okay, or our starting x value and finishing x value, if you want to think about it that way. Okay, so if you want to work out the area, well, let's say we know what y is. Let's give a function for y. So let's say we know that y is equal to x cubed plus 4x squared. Okay, actually let's do just 4x. There we go. X cubed plus 4x. So what we want to do here is we want to integrate x cubed plus 4x with respect to x, but we want to have these limits. So we want to put the 0 and 1 at the bottom and top of that integral sign. Okay. All right, so let's follow this rule that we've got so far. So let's actually do the integration. So x cubed, let's integrate x cubed. The power goes up by 1, divide by the new power. So power goes up by 1, x to the 4. But I've got to divide by the new power, so I've got to divide by 4. Let's have a look at the next one. We've got 4x, the power goes up by 1, so 4x squared. But I have to divide by the new power. And I'll have a plus c. So I've followed my 3 steps there. Okay, so that pretty much looks like what we had to start off with. However, we've got to think about those limits. So I'm going to put square brackets around everything, and I'm going to write down those limits on the right-hand side of those brackets. Okay, how do I use these limits? So actually, before we use these limits, let's tidy this up slightly. So we've got x to the 4 over 4, and then this 4x over 2, the 4 and the 2, 4 divided by 2 is equal to 2, so we've got 2x squared plus c. Okay. All right, so now let's think about what's going to happen. So what we need to do is somehow replace these x values with the 1 and the zeros. So to do that, we do the upper limit first. So 1 to the power of 4 divided by 4 plus 2 times 1 squared plus c. So this is that square bracket with the upper limits substituted in. And from there, what we want to do is take away, so this is minus, the same idea, but with a lower limit substituted in. So in this case, we'd have 0 to the 4 over 4 plus 2 times 0 squared plus c. So 0 to the 4 is just 0. 0 squared is 0. So that second bracket just gives me a plus c inside it. Let's have a look at tidying up the first one. Let me just mention this over here. So this is with the lower limits. All right, so let's tidy up our brackets. 1 squared is 1, so if you put this, you put that in your calculator, we'll have 1 over 4 plus 2 plus c. And then in the second bracket, I've just got c. So c, take away c is 0. Those c's always cancel out. So even though we have that plus c and we don't know what it is, it doesn't matter if you're finding an area because the c's just cancel out. And in our case, we are left with 1/4 plus 2, so 2.25, an area of 2.25 in this case. Okay. Why does this matter? Why is this useful? So in the next video, we'll look at using this in an engineering application, if you like.